My name is Vid Jain, and I'm founder of Wallaroo Labs. And what we do is help people build data applications that run at scale without having to think about the scale of the infrastructure. And if you think about it, our modern world is really driven by data. We generate data, we consume data, we interact with data services and applications. And this is happening more and more. So before I go into the details, just a few quick things. Well, Andy actually is going to at some point do a demo, so he's setting it up. But we're VC funded. We have 5 great VCs. We're based in New York. And we have a lot of great advisors. So I want to tell you a little bit about my background and the team's background. So we're 11 people, and we all came from building data applications. Some of us came from high-speed electronic trading. Other people came from open source and other startups. And what we found is that there's still a lot of complexity and cost in building these kinds of data applications. And my background in particular is I spent 8 years helping to essentially replace 2,000 human traders with algorithms. So that was all about huge amounts of data, looking at historical data and building trading models, running those trading models at very high frequency against incoming market data, and then also collecting everything that happens so that you can report for compliance purposes, and you can manage the risks. So this complexity or cost of building these kinds of applications, though, is not unique to financial services applications. So a very simple example of that is if I gave any developer, here's 1 million tweets on your laptop, right? The algorithm for doing that is that simple. I take those tweets, I split them into words. I take, I count each of the words and I put the results, right? You can do it over a coffee in a couple of hours. But then I go in and I talk to CTOs or I talk to data scientists, and I say, how long does it take to do that at large scale with a lot of data across a whole bunch of servers where clients are looking at it, and so it's reliable, right? And the answer sometimes is a few weeks. The answer sometimes is a few months, but typically it's like a couple of months. So all of a sudden, to productionize this very simple algorithm, you're spending 2 months, and 99% of that time is not on the algorithm. It's actually on the infrastructure plumbing. How do I get this data across a bunch of machines? How do I make sure that the results are all combined and coordinated? What happens if I lose some data? What happens if a process goes down? And then you get it up and running, and then the volumes go up, and then that's not 2 hours of work, right? That's a few weeks maybe of additional work, and then guess what? You did such a great job that your boss is like, hey, let's do some sentiment analysis now on that data and figure out if that new iPhone is going to sell like hotcakes or it's too expensive, right? And then you're ready to pull out your hair because at each stage dealing with scaling and operating and running this thing across a bunch of servers is 99% of the work. So, and this is not just true of financial applications or Twitter trending topics. This is almost every application that you can think of, right? Which is anywhere from detecting whether a robotic arm in a manufacturing line has drilled a hole in the wafer in the wrong place. That actually can happen in a few microseconds. All the way to you've got petabytes of data and you need to do a long-running analysis, and it needs to run for hours. And so the use cases here are thousands, and I've listed a few of them. These are actual use cases where we are talking to people or people have come to us with these particular problems. This is just a few of them. But when we started building Wallaroo, there were 3 trends that really informed us, right? And I want to back up a little bit and talk about these trends. Because they're really important trends that are going to impact how these applications are built, where they're deployed, and at what scale they need to run at. And one of them I've already alluded to, which is that there's more and more data, and more applications dealing with data, and this data is arriving 60% faster every year. So that means in 5 years, you're going to have 10 times more data. It's going to arrive 10 times faster. And not only that, there are more and more sources of data, and the algorithms are getting more sophisticated and multiplying. So you may end up needing 20 times or 50 times or 100 times more processing power in 5 years. So whatever people are doing now, whether they have custom code that they built or they're using existing tools, something sooner or later is going to break. It's going to get too expensive. It's not going to perform at the way you need it to. You're going to spend tons of people trying to manage that whole infrastructure. So that's one very important, big trend that's going to impact these applications. The second one is that these applications have to be built in some programming language, right? And a lot of people maybe here are familiar with building these kinds of streaming data or big data applications in Java. But guess what? There are people doing it in all sorts of other languages as well. And Python in particular is going to overtake Java next year for data applications. And it's growing something like 25% a year. And you have other languages too. We're actually, we have interest in Golang. We've actually got people interested in JavaScript. And you know, if you're in an enterprise and you're working with enterprise applications, sometimes people a little bit scoff at these other languages. They're like, you know, okay, some young kid out of like college is doing some thing in JavaScript or Python, but these languages are serious languages now, and they have a whole ecosystem. And you know, our goal is you know, why not? Why shouldn't people use those languages? The other big trend is that computing and data are moving outside of the enterprise data center, right? So you've got edge servers where they're collecting all sorts of device data, and analytics is happening on those edge servers. You've got cloud computing. You've got the Internet of Things generating, you know, by some measure, 200 billion messages a second by 2020. So how are you going to process all those messages? How are you going to you know, get your results in a cost-effective manner? Because that's a huge amount of data, and at today's cost structure, it's unmanageable. It's not going to happen, right? So we took all these things into account, and we've really been thinking about where does data processing and data computing need to go over the next few years, right? So our goals are really twofold. One is to democratize these kinds of applications so developers can code in whatever language they want. Yeah, there's surely people that love to use Java, and that's fine. There's other people that are okay with using Python, going back and forth with Java. That's fine too. But there's a whole host of other developers that would be happier working just in those languages that they prefer. And then they can leverage their existing knowledge. They can use the libraries that they are familiar with. They can use all the machine learning analytics or whatever that are already implemented in, say, Python or some tool that they're using in some other language. And because you don't need to deal with the infrastructure, you get a lot more done faster. And then we also want to equip businesses for the future, right? So how are you going to deal with this massive data growth without breaking the bank? It's already too costly. If I just take a linear extrapolation, that cost structure with that extra data is just not bearable, right? And then because of all these different places where stuff needs to run or data is being generated, you know, you don't want to be locked into running in a particular environment. So those are the things. And again, I just want to emphasize, infrastructure plumbing is hard, right? In your home, you don't, when you want the water to come out, you just turn the dials. You're not going in there dealing with how the plumbing works and how everything is connected, right? So our goal is to let people focus on what they're really good at and what they really want to do, which are the algorithms and understanding the data and extracting value from there. Wallaroo is really designed to take care of the infrastructure, right? So wouldn't it be great if the infrastructure just disappeared so you could do this, right? And that's really what Wallaroo does. It's an open source framework for building and operating fast data, big data, and machine learning applications. So it essentially sits as a layer between your algorithms and the infrastructure. And so you can deploy rapidly. You can write a piece of code, and we'll show you a demo later, where you write a piece of code which is not that complicated. And that piece of code will run on one server or two servers or three servers or 10 servers, and you don't need to do anything. It scales automatically. It can run while it's running. You can add capacity or shrink capacity. And it operates at very low cost, at very high performance. We just launched the Python version, open source, a few weeks ago. and that's initially for stream processing, but we do have batch features and other languages coming soon. We actually have versions of Golang and C++ already working, and we got some pilots underway there, but we're going to be coming, as I mentioned, JavaScript. We'll be coming out with the JavaScript version. And there's no Java needed. So again, if you love Java and you want to use Java and you love Java with Python or you love Java with JavaScript and you want Java and everything, that's fine. But if you prefer to use other languages natively, you want to run Python in the standard Python interpreter, then that's something that we provide. Very, very low overhead. So if you're working in Python, Wallaroo for Python is about 4 times faster than writing your code in pure Python. And it has 1 to 2 millisecond latency for some applications if you're trying to do real-time processing. If you're using other languages, it's 2 to 4 microseconds. And you can process in an event-by-event basis on a single 16 CPU server 200 billion messages a day. Again, results depend on your specific application. If you got a lot of application code that's running for seconds, then you're not going to see those results. But for many realistic use cases, it is extremely low overhead and high performance. It also allows a very systematic approach to how you deal with data, right? Because you're not just dealing with data in your business in one place. You've got a fire hose of data coming in. You need to enrich it. You need to streamline it. You need to store it somewhere. And then you've got, you're taking that data and you're taking training sets and doing model training on it. Then you're taking the outputs of those and you're running it in real time and providing a service or doing transactions or looking for fraud or whatever it is. And what we typically see as we go in and talk to people is that they're doing, Spark over here and Storm over here and some Python thing over here and some other thing over there. And they've got a very complicated sort of tropical forest of technologies. And so we're hoping to simplify that. A couple other things, and then we want to show you a demo. So one is people ask, well, how are you guys different than serverless, right? So we're not serverless, let me be clear. But we are related to serverless in that we have 2 of the same goals. One is that we want people to get more productive with the utilization of the infrastructure, right? And secondly, we don't want you to think about infrastructure. The difference is that serverless typically only applies to certain kinds of use cases or ideal for certain kinds of use cases. So in a serverless architecture framework like Amazon Lambda, there's no state. There's no in-memory state. Your application can't remember anything in its memory. Because every time a message comes in or a piece of data comes in, a new instance of your code is launched, right? So that means you can't remember anything. And number 2, you have number 2, you can't run for very long. You have to shut down in 5 minutes. And number 3, it's not very high performance. And number 4, you're tied to a particular place that you're running at. So in our case, we are actually targeting all those other use cases. We're also, people ask, oh, how is it different than, say, Spark or Storm? And again, I think I've already said these points, but we're really great when you want to work in a different language. You need very fast response. You want to be able to scale up and down in your environment without thinking about it. And so now I want to just quickly take 30 seconds to go through this, and then we're going to do a little demo. So I talked about trending topics, and this is very similar to streaming word counts. It's really 4 steps, right? You take in the data, you split it into words, you count the words, you output the results, and you can do it over coffee. So this is what the code looks like if you write it in Python to run on a single CPU, right? It fits on a page. OK, great. You do it, a couple of hours to run, you debug a couple of things. This is what the code looks like if you use Wallaroo. It still fits on a page. It's actually just a few extra lines of code. And if you look at some of that code, like splitting into words, it's just standard Python code. There's nothing fancy. Anybody who writes in Python can look at that and understand what it does, right? So now, let me tell you before we do the demo what it's going to do. So let's say I start this code on one worker, right? And in this case, I'm going to take a stream of words, and I'm going to count them in real time and output the results. So China 1,274. Nothing, no big deal. Looks just like the one CPU version. But now what I can do is I can start another worker, right, that joins the initial worker. It actually moves state over while it's running. It's not like you have to restart or redeploy. It actually just moves state over. And then the state is split automatically. It's moved over. The thing is running. It's now running on 2. And I can keep going. And going and going and going. And this is live scaling. There's no change. That same one page of code is doing all the stuff. So we're not built on Spark. So I'm not really sure what the Spark question is about. But if you want to use Kafka, for example, we actually integrated with Kafka. And what we do provide is we have a suite of testing tools. So if you are writing an application and you want to test whether everything is integrated and working correctly, then you can use these testing tools to send in data to have your application run, to output results and compare what was expected to what was actually happened, to what actually happened. And we designed these tools because in these tools you can simulate failures. So you can simulate like there's a network outage or a server crashes or a process crashes, and then it will actually, it should proceed as though nothing happened, and then you can compare. So you can use these, we provide these tools as part of the open source release. Okay, I guess we're not going to have the demo.
Since Spark is becomes such a popular execution engine, do you have any type of integration with Spark, any type of support of Spark?
So it depends on who I'm targeting. Right now, when I go and talk to people, the main value proposition and the main thing people are interested in is the fact that they don't need to use Spark and they don't need to use Storm. That they'd rather just write their code in Golang or in Python and not have to deal with Java or the JVM. That's different at these large enterprises where they have large amounts of people my age that know Java. But at the younger, smaller companies, they're not so hot on Java or the JVM. So whether should I have a Java strategy and should I integrate with Spark, that's not my primary concern right now because I haven't found anybody that's asking me to integrate with Spark yet. So when that happens, that's fine. I can figure out what that is. What I have found are people that prototype in something like Python and then they productionize in Java. And what they're interested in is a simple API that allows them to go from their Python prototype into a Java production environment without having to rewrite the whole thing. So that is something which does make sense for us to do, but not immediately.
One last quick one. Hi, any problem with Israel compliance if you run anything with credit card numbers?
No, I mean not that I've seen any so far.
Good. Well, on that note, thank you very much. Appreciate it.
Okay, thank you.